Hi, Vintage Stereo Buff. The postman brought me a new toy yesterday, Crossfire power amp. I was not familiar with this. I didn't know if it was American or foreign made or how old it was. But it was only $45 and it looked really nice. It says here, designed and engineered in the USA, but it was manufactured in Korea. But it still looks like a pretty nice amp. Let me turn it over and I'll show you the inside. It's a 75 watt per channel into 4 ohm amp. Got pretty good size transistors here. And this is a bridgeable amp. And I'm not a technician, but I know a little bit about amps, and maybe I could explain a little bit to somebody who doesn't know. But on here, this ground wire will come in and it'll connect to this ground bus, which connects it to a multitude of other places on the amplifier. And then this power wire here, the plus wire, comes in through these two filter capacitors and this inductor coil to filter out the noise from the electrical system, like the alternator. And this hot goes to these coil, it goes over to the center leg on these 4 transistors that are power supply transistors. The ground wire goes on each side here of each transistor. Power wire goes to the center pin of each transistor. And the power wire also goes to this pulse width modulator. This is a little brain that tells these transistors to switch off and on about 50,000 times a second. The reason for that is we need to induce a voltage into this transformer and transform it. And a transformer only works on AC. It works on the collapsing and expanding magnetic field caused by the voltage. So, in order to get that from DC, we run this DC through these transistors. This thing switches 2 of the transistors, or all of them. It switches all of them off and on. 2 on at a time, and then these two on at a time. And this is one will be on a positive side and one will be on a negative side. And they'll induce a voltage in this coil. It'll go from 0 to positive, and then it'll switch, and this one will go from 0 down to negative. This mimics alternating current in the magnetic field and induces a voltage in the secondary coil. There are more turns on the secondary coil than there are on the primary, so we can step the voltage up. Down here, say, would maybe be, if it were 12 volts here, then it would step it up to, say, 24 here. So I'm not sure what the exact voltages are here yet. I haven't tested them. But after it converts this to the higher voltage in AC, we need to store it in these capacitors. But the problem is the capacitor won't store AC. So what we have to do is we run this through these 2 rectifiers, and they change it back to direct current. And they store it in these capacitors right here to be used by the output transistors. But for the time being, the juice is just stored in here. It's not going anywhere until we get a signal from in here, a sine wave signal from in here. Now it'll run in through here. I'm not going to go into detail on this. This is just a lot of little filtering and crossovers and equalization buttons and some other things. But when the signal from here goes through these and turns this off and on. There are 4 little transistors here and 4 little ones here, and I believe that they're driver transistors. And then there are also 2 transistors here and here. Now maybe they're the driver transistors, and 2 here, or maybe there are 2 sets, these and then these drivers, because the input signal isn't strong enough to drive these outputs. So we run it through these, which are basically little preamplifiers, and then I guess this would be the second stage of preamps, and then we run it into these power amps. Now how we achieve the bridging on this type amp is, on one side over here, the hot leg of the output transistors will go to, say, the right positive. And on the opposite side over here, channel, the hot leg of the transistor will go to the negative of the left channel. So that the right of the left channel, or the positive of the left channel and the negative of the right channel are tied together electrically. And they're tied together right in between these 2 capacitors, which act as a voltage divider. This is how we get the bridged output. That's why it's double of what this and that is. They're basically 2 amplifiers stacked on top of each other. It's the way I look at it. And but anyway, I'll go ahead and turn it on, and we'll see how it works. I think I have it turned on, all hooked up. And maybe take a measurement or 2. Well, that works. So now, well, through the magic of YouTube, I have it flipped over, turned on, and we'll run a little test tone. And I'm going to measure the voltage across the bridged output. And you can see on the meter over here the reading. Now I'll turn this up. So the amplifier will output, with the gain fully up and what I'm doing, this turned up where I am now, will output 56.6 volts at the output with the gain all the way up. That's pretty good. Then I'll turn it down. Now, watch this. But this is what is confusing to me. The voltage across these primaries is 63 volts. The voltage across these 2 in the center position is 28.4. And over here, 27, which comes to about 56. But when I measure it here, I have 63 volts. And that's on the primary side. What I don't quite understand is how we obtain that high a voltage on the primary side. And then when I measure the voltage here on the secondary side, I've actually got 147 volts. And this is another thing that's funny. Half of 147 would be less than 75, correct? But When I measure from a center tap position, I get 82 volts on that side, and I get 80, well, almost 79 on that side, which should come to close to 160. It should be about 159. But yet, when I measure across these, I only get 147, a 12 volt difference. I don't understand that, unless it has something to do with the transformer action. Maybe it's saturation or something. But this is what confuses me most, is why the primary, where does the primary coil get 63 volts? How do we obtain 63 volts AC from a 12 volt DC source? Doesn't make a lot of sense to me. If anybody could explain it that knows more about these amps, I would appreciate it. I can always stand a little constructive criticism and correction. So if anybody knows, drop me a comment. Anyway, vintage stereo by Fab. I think we'll